So welcome to the next class. What I'm going to do right now is give you a little bit of a discussion that we touched upon last time, having to do with the use of a gang of four pattern in Android as it pertains to activities. That's one of the themes we're going to cover a lot in this class, is how Android relates to patterns. And there's a variety of different reasons for doing that. Number one, it's interesting to see how modern software product lines, frameworks, etc., are heavily pattern-oriented. So that's a good example of the stuff that you have learned about earlier, perhaps, if you've taken some of the other courses here in the CS program. You'll have a way to leverage the knowledge there. But it's also more important because it's teaching you generalizable design experience and design expertise that you can leverage in your own code above and beyond what Android provides. And so once you understand the patterns, then you not only understand how Android works better, both in terms of how it's implemented and how to use it effectively, but you also hopefully get a chance to either learn or relearn the more general concept of applying patterns for your own purposes. So that's sort of why we're going to cover the pattern-oriented piece. And that's also something that if you were just to watch videos on the web about how to program Android or read a run-of-the-mill book on Android programming, you wouldn't really get exposed to that dimension probably. People tend not to talk about that as much as they probably should. So the particular pattern that we're going to talk about here is one of the classics from the Gang of Four book. It's called the template method pattern. And if you remember, for those of you who took CS 251, the template method pattern is something that we use there to be able to toggle back and forth between verbose mode and succinct mode for our expression tree processing application. If you didn't take the class, that will make no sense whatsoever. But that was one of the things we used to help keep the code fairly common and then be able to have just a variation at the edge of this design with respect to whether we were verbose or succinct in the way in which we interacted with the user. Android uses this pattern also and in a totally different way, but we're going to talk about what the pattern's about. So the intent of the template method pattern is to define an algorithm or portions of an algorithm and leave certain parts up to the subclass to define. And that's because the basic algorithm doesn't have enough knowledge to do all the parts, but it does as much as it can in order to maximize systematic reuse, and then it delegates the parts it doesn't quite know how to do to hook methods that are called on code that you extend or customize or compose somehow in order to be able to get the specific behavior that's important. Obviously, you can read more about this in the Gang of Four book, or if for some reason you don't have copies of the Gang of Four book, you can take a look at Wikipedia, which has a pretty good overview of the template method pattern. So when would you apply this pattern? Well, there's a couple different situations. If you want to be able to implement variant aspects of an algorithm once, implement invariant aspects of the algorithm once, the things that don't change, and then be able to defer the variant parts to subclasses. So right away, you should see why this thing gets applied a lot in Android, because Android is full of frameworks and it's product lines and so on. And this concept of commonality and variability is very important there. So we're going to look in a second about how this actually gets used in the context of Android. What you typically do in Android with stuff like activities is there's a base class that is defined called activity, and then you inherit from that and you fill in certain variant parts, certain things that may change on an application-to-application basis. You also would apply this pattern if you want to be able to localize common behavior in a class to increase the reuse of code. So if you take a look at the implementation of how Android implements activities, and we'll look at specifics of it here shortly, what you'll see is that there's a lot of code that goes into the activity abstraction that's buried underneath the hood. You don't see it as a user of activities. It's part of the framework developer's realm of concern. And that is finding very sophisticated, very complicated checks for the way things occur, getting a lot of stuff set up, caching certain states, being able to instrument the code, dealing with threading, all kinds of stuff that happens behind the scenes. And then what is done there is that code is then packaged up in a reusable way, and then your code gets called back, but you didn't have to write all that other code. In fact, you don't even really have to know much about its existence unless you see how the template method pattern is actually implemented in Android. And we'll take a look at that in just a second. Another thing you can do with this pattern is you can control subclass extensions. You can decide, you, the end user, can decide what customizations and what variations are handled and how you want them handled. For simple examples like this, it's pretty straightforward. in more sophisticated uses of template method, you actually may have many different methods or many different hooks, each of which can have many different variations. And then you have to kind of keep track of all those variations and make sure you don't mix and match things incorrectly. With Android, it's typically pretty straightforward because you typically inherit from the activity class, or you inherit from a class and inherit from activity, like our lifecycle class that we looked at before, lifecycle logging activity class. And then you fill in the blanks, but they're almost always done within the context of the subclass that you inherit from activity. Very rarely have 3 or 4 of these. So here's a recap or a description for those of you who have never seen this pattern before of what the structural parts of the template method pattern look like. So what you have is you have some abstract class which defines at least one method that we term a template method. We'll talk more about that in a second. And the implementation of the template method is defined in part by invocations to so-called primitive methods, or what I like to call hook methods. It's a bit more descriptive than primitive method, because the primitive methods could actually be very complicated for that matter. But the hook methods or primitive methods are the things that are perhaps not actually defined in the base class at all, but instead they're intended to be customized and overridden in the subclass. So for those of you who've taken CS 101 or 102 here, or 251, you may recall that one of the fundamental principles of object-oriented design and programming is this idea of having a base class or an abstract base class that defines a set of methods that are obligations on subclasses to override. In Java, we call these abstract methods. In C++, we call these virtual methods or virtual methods. And it's either necessary for the subclass to override them, or it's possible for the subclass to override them in order to do different kinds of things. So in our particular mapping of this pattern onto Android, the activity class itself is the abstract class, and we'll see that there's a couple different methods that are template methods in that context, none of which you actually call directly. That's done for you by the framework. And then you come along and you provide your own activity, like for our particular example, it might be map location activity, or lifecycle logging activity, or whatever thing is inheriting from activity. And then you fill in one or more, or typically at least one, of the methods that are part of the activity base class that need to be overridden in order for the activity to do something useful, to create itself, or pause itself, or destroy itself, etc. Any questions about that? So you can see there's a pretty nice mapping from the abstraction that Android provides onto the activity abstraction that Android provides onto the parts of the pattern. So let's take a look and see how this actually works in Android. And that's what I was mentioning in some of the earlier parts of the class. It's really cool that in Android you can get access to the source code, or some variant of the source code, and you can look at this and see how it is they do the various things we talk about. So you don't just have to work at the edges of the system. You can actually dive deep down into the core part of the frameworks, the virtual machine, even the operating systems and some of its drivers are available for access and inspection as well. So if you take a look at the activity class, and for those of you who have access to the Android source code, it's in frameworks, base core, Java, Android app / activity Java. That would be the particular one here. And there's some other files that are important too, like instrumentation.java or activity-thread.java that we'll mention along the way as well. So basically what happens is you have this activity class, and in there is a method, a final method, which means it's not going to be subclass by anybody else. It's the final implementation. That's called perform start. If you go and look at the perform start method, it's probably 3 lines long, 2 lines long. It's got a lot of stuff going on in there. And one of the things it does while it's running is it calls out to M instrumentation, which is just a data member, dot call activity on start, and it passes itself in, passes the activity, this method, in to that method. And so that's the template method. It does a set of things. One of the things it does is to call this helper method. And this helper method, if you take a look and see what it does, it just turns around and it takes the activity parameter passed to it, which is this, the activity context, the perform start activity context, and it says, hey, activity, start yourself, calls the on start hook method. And that, of course, is what's dispatching the method that you would write. Now, if you poke around a bit, and we'll see some examples of this in just a minute, there's other places in the code that's part of the activity implementation ecosystem that does other callbacks to other methods that are hook methods on activity. So the things in there that deal with start stopping, that's actually done by the activity class itself with perform start, perform stop. And then there's other things, other places that call other things like on create and on destroy and so on. But if you look through the code, you'll see where all those things are invoked as callbacks in various ways. That's kind of how it works there. So let's now talk about some of the consequences of applying this particular pattern. So one of the things that this pattern does is it enables inversion of control. You're not actually in charge of the event loop. The framework is in charge of the event loop. And you just, if you think about your program that you write to do the first assignment here, the first programming assignment, there's very little you have to do other than just create an activity subclass and fill in some of its methods. You don't have to write a main program, main function. You don't have to do much of anything else. It's all sort of done for you by the environment. And that's all due to the magic of inversion of control. And inversion of control is sometimes referred to humorously as the Hollywood principle. We talked about that before. Let's go ahead and see if we can pop up the Hollywood principle article on my website. That guy. We'll open up a browser. This is an article written by the late John Glassides, one of the Gang of Four authors, and it appeared in a column in the C++ Report magazine many years ago in 1996. I was actually the editor-in-chief of the C++ Report magazine back in those days. And he has an article there that you can get on my website that talks about the Hollywood principle. And the whole thing is about inversion of control, calling you back when something happens. So take a look at that. He gives a bunch of examples of how to do this. It talks a bit about how it relates back to the template method pattern, and he gives some examples in the context of a file system, which is completely different application from Android, but the pattern is the same. So from an inversion of control point of view, there's something called an activity thread, and that's responsible for getting the activity up and running. And one of the methods, if you poke around in the source code of Android, you'll find that there's a method in the activity thread class called perform launch activity. And in that method is a call to perform start on the activity. And so you can kind of see what happens here. Sort of shows the interaction. Activity thread, which is sort of running in the background in the framework context, goes ahead and calls perform start. That ends up calling call activity on start, which ends up calling the on start activity on the object subclass that you define. And that goes ahead and kind of kicks things off. That's one of the benefits, inversion of control. You don't have to worry about how the event is run. Just worry about doing something when things call you back. Another very important consequence of applying this pattern is it helps to enhance code reuse by collapsing stovepipes. So this particular example doesn't illustrate that in enough detail, but the basic idea is that lots and lots of code, namely all the code that is part of the activity implementation and all the other things that are used to run an app in the context of Android, are all reusable. They're all stuck into the framework. And there's all kinds of interesting take place there. For example, there's a check to make sure that you call back the superclass when you do an onCreate, and if you don't do that, then that can happen and so on. And those things are all enforced by the framework. And so what you can end up doing is there's a lot of reusable code, namely all of Android, and the part that is the common code, and then there's the variant part. Point up here. There's the variant part, which is what you write. And as you can see from the background, there's a little bit of variant part and a lot of invariant part. And that's the power of systematic reuse. All the stuff that's going on under the hood, you didn't have to write. You don't really even have to understand. You just have to understand the rules of the framework for how to customize what's defined there. And then you can also come along and override and customize things as you see fit. Now, one of the other consequences about this, there's a couple other negative consequences, is that if you're not careful, you can have an explosion of subclasses. Template method works by customizing and subclassing from a base class. And so this particular case doesn't illustrate this point, because there's really only one subclass or maybe two subclasses for each different activity. But in a more complicated use case of template method, you can have lots and lots of different subclasses, and they may have some interesting interactions with each other. And if you're not careful, you can end up in a situation where you end up repeating yourself a lot. It's very brittle and hard to change. It's difficult to modify on the fly, and so on. So there's another pattern which we'll cover later called the strategy pattern. And those of you taking 251, or if you're interested, you can go back and watch the Coursera videos I did on strategy versus template method, and I'll talk about trade-offs between these different patterns. Another thing to note, which I didn't write down here, but I probably should, is that with template method, go ahead and do that real quick, or at least leave myself a hook to talk about this. One of the other downsides of template method is the challenge of validation. And the reason for this, the reason why validation becomes tricky, is because when you write a framework, there's certain things that will have a big impact on whether the framework works properly that the framework doesn't actually control. So, for example, let's say, for sake of argument, that Android framework is completely free of bugs. Hard to believe, but let's assume it's true. When it calls back to your onStop method, or it calls back to your onCreate method, or it calls back to your onPause method, or whatever method it calls back on, at that point, it's giving up control. It's letting you do something. And you could do something completely goofy. You could go into an infinite loop. You could cause deadlock. You could have all kinds of other things. You could do stuff that would corrupt other parts of the state of your application, or maybe even the state of the framework, depending on what you do. And there's nothing Android portions, the reusable part, can really do other than normal Java. So it's hard to figure out whether or not the framework is correct if part of its behavior depends on callbacks to user-defined. Verification and validation become trickier because the correctness of the reusable stuff is to some extent dependent on the correct behavior of the thing you're calling back to. Now, that's nothing to be alarmed about. It's just an observation that people building frameworks cannot assure everything will always go as planned. Now, the Android system does try to do a little bit of other checking to make sure that you don't do totally crazy things, or if you do crazy things, you only do them for a certain amount of time. So, for example, if your callback methods go and block for a long period of time, or they go into an infinite loop, or some other kind of hang, then after a certain time, 5 seconds or so, the Android runtime will say, aha, nobody's responded. The window manager will say, this guy hasn't responded in a while. He must be hung. I'm going to shut him down. There are ways to clean stuff up, but the point there is that has to be done at a higher level in the overall system architecture. There's a bunch of implementation issues with respect to template method. Do you make the template method be virtual or non-virtual? In Java, that would be a final method. In C++, that would just be a non-virtual method or a static method. In the case of Android, you can see that the perform start method is final, which means we're not going to customize it. In many cases, you don't even know it exists, so you wouldn't be able to customize it. But it's defined as a non-virtual method. Sometimes the template method is defined as a virtual method. Can anybody think of a reason why you would define the template method to be virtual? What would the benefit of that be from a design point of view? No? Well, actually, you usually don't want to override the template method. You usually want to override the hook methods, the primitive methods. So that's why oftentimes you don't make the template method virtual, just because you don't want to encourage people to override it, because you have a certain fixed algorithm in mind. Yeah. You can certainly set pressure on subclasses, but to the extent that you can handle that by, like we do that in assignment number 1, we have lifecycle logging activity, and lifecycle logging activity inherits from activity, and then you subclass from that. But as long as you can live by just inheriting from onCreate, onStart, onStop, you're still fine. Patrick? Right. So the basic observation was you could come along and allow someone else to inherit and then customize the framework itself. More generally, what Patrick is saying is if the default skeleton of an algorithm happens to be such that it doesn't always do exactly what you want, even with those hook methods defined, and you need to come back and customize the skeleton of the algorithm itself, then making the template method virtual allows you to override that as well. Now, you have to be very careful of that, of course, because if you start changing the behavior of the template method willy-nilly, then anybody else who is assuming that the hook methods alone were sufficient might be in for a surprise. For example, if your customized template method in some subclass doesn't call back to some of the hook methods the same way that the original method did, then code may be in for a shock because it won't work properly. But there may be some things that you might want to add: logging, instrumentation, debugging, other kinds of things that might be beneficial to leave those template methods as something that's potentially overridable. Any questions about that? So as a framework developer, you have to think these things through. As a framework user, the framework developers either decided for you and said, nope, can't subclass, or they haven't. If they decided you can't subclass, all you have are the hook methods. If they decided that they would make the template method virtual, then you have to decide how much do I really need to know about the guts of this thing in order to make this work. Another question is, do you have lots of primitive operations? Do you have a few of them? As you can see in the activity context, we have 6 or 7 of them, depending on how you count it, do the various lifecycle operations. So that's a pretty straightforward thing to do. And then, as a rather mundane point, how do you name the hook methods? You call them do whatever, do you call them make whatever, do you call them on whatever, and directly you call them on convention, on start, on stop. That's obviously a very, very low level and somewhat insignificant. Glasses. Ah, there you go. There's a deadlock, potential deadlock situation there. Okay, so to kind of wrap up this discussion, template method is a very, very widely used pattern. It's very heavily used in windowing systems. It's very heavily used in middleware. We use it a lot in the middleware we've developed for many years in C++. As you can see, it's used in Java toolkits like AWT and many, many other places. And it's also used in Android. The activity framework is one example. There's other examples as well, like async tasks, where we talked about that as well. Okay. Any questions about template method? So, again, good pattern to get to know. You may have been familiar with it already. You'll see a lot of it used throughout the course. You may also want to use it for some of the things you develop later. All right. So as promised, the real focus of this class is to give you some more examples and prepare you for the programming assignment that's due on Monday. And as I mentioned before, that programming assignment has to do with this map location application. So what we're going to do now is we're going to talk about this, and I'm also going to see if I can show you examples of some of the things I'm talking about as we go through this. And we'll look at some of the code, and I'll run the application on my phone, and if the debugger is working in our favor, you'll get to see the application come out in the logger and so on. So what we're going to do is we're going to talk about when the different methods get called, talk about the application, and also just talk more generally about how things work. So the onCreate method is it's sort of like a virtual constructor, if you will. Its purpose in life is to initialize the activity when the app is first launched. And typically what it does is it initializes any state that's global to the activity, which most likely is going to be instance variables inside of the activity object, but it's going to survive through all the different lifecycle calls until it gets shut down, although it may get parked for a while, depending on what happens. So typically it'll call up to its super class and say, super onCreate, and that stacks some information away for initialization purposes. It'll inflate and configure various user interface views as necessary. It'll set the content view of the activity, which is your learning, if you're doing the assignment, is something that's typically defined declaratively. You can use various means to do that. You can either write the XML file yourself, or you can use the activity UI builder that comes with Android's Eclipse environment to do that. So here is a little snippet of the code, and what I will do is see if I can go over to Eclipse, and let's try to start this thing up and run it. come over here and we say run to run this particular activity, and I want it to run on my smartphone. So let's click that, say OK, go over here to the DDMS view and click on this thing and then take a snapshot. In a minute, I'll show you a cooler way to do this than what I'm about to do here. So as you can see, that's basically a snapshot of my phone. And what I want you to do, clear out the, oops. So you should be able to see the logs flashing by here at the bottom. It's a little bit hard to see because of the font size, but let's go ahead and try. So I'm going to go ahead and enter in an address, and I'll show it to you when I get it entered in. Okay, so refresh this guy. All right, so that's my address. And now let's go ahead and show this thing. And what's happening here is that it's coming up, and it says, there it is. Rotate it so you can see a little better. There it is. Okay, so that's basically the application that's being run. Go ahead and a couple things. Let's go back and see if we can. There we go. So while that was all taking place, it's a little bit hard to see this just because the resolution is rather coarse, but this is the logger that was running while that was taking place. If done a little bit differently, it would have been. So it starts right there. So these are the callbacks that are taking place as the thing becomes visible and so on. It's created, started, resumed. And then when we switched over to the mode that was showing the map, our application is now no longer visible. So it's basically going to be paused and stopped. And then when we were all done, I hit the back arrow and it went ahead and destroyed it. Destroyed. So those are basically the lifecycle calls that are done there. What I'm going to do now, I just wanted to show you that that's a nice way to tell what's happening under the hood as your application is running. What I'm going to do now is start this cool little program that Zach gave me, and it's basically a jar file you can use, and it'll show your screen in real time. Let me make that just a tiny bit bigger. It's too small. There we go. That's the right size. So now you can basically come up here, and it's not super duper fast, but it's not too bad. So it'll basically show what you're doing in real time. So it's a little bit better than all the time. Okay, so let's kind of keep that around. We'll come back and look at that as we see fit. So let's take a look at the code for doing this stuff. This is the onCreate code. You can see here we have map location, extends activity. We give it a tag name that's going to be used to keep track of what the application is. We use this for the logger. If you take a look back over here, you can see that that's what's being put out as the tag when this thing runs. And I've filtered for things just related to your application so I don't see all the other events. And I'm also just looking at info related messages in the file. I'm not looking at some of the more serious messages because I don't want to be distracted on the screen. So here's the onCreate hook. We'll talk more about this in a second. I guess I should go back to the slides for just a sec. So this is basically that code. First thing we do is we call up to our superclass and say, hey, create me, please. And then we set the activities content view. We'll talk more about that on Monday, how that all works. But we're essentially saying, here's how I want the layout to occur on the screen of the phone. And then we set up a bunch of things that configure the way the user interface is going to work. So let's take a closer look at that code. And I also print out a little message just saying, hey, we're being created. So this is not exactly how I want you to write your code. I'm just showing you the basic idea. So the first thing you do is you go out and you find the resources that you care about, the address, the edit widget that will be used to enter in the address of this particular application. For your application, you're going to have two of these, one for latitude, one for longitude. In this case, I just have one. And then I create myself a button, which I defined also in my file to describe the content layout. And then down here, I go ahead and set a click listener. So you can see this is a good example of using anonymous types or anonymous objects in Android. Let me make this a little bit smaller so you can see more of the screen. Yeah. So we make ourselves a new click listener, and we make that to be the thing that handles whatever occurs when you click that button, which says basically find the address or map the address. And then we override the onClick method, and this does a bunch of stuff. It goes ahead and grabs whatever the user typed in, and we do a little magic to replace spaces with plus signs so that things work properly with the syntax by the Google Maps applications. And then we create ourselves a new intent, which in our particular case, we're going to use the geo intent. And this particular piece of code will only work if I'm running on a phone and Google Maps installed. In particular, it's not going to work on the browser or sorry, on the internet. Then I come down here and I do a little bit of magic using the package manager to see whether there's a handler that knows how to handle this particular kind of intent. The intent is an intent that is got the URI type of geo intent plus the address. And if it's not, in other words, if I'm running this thing inside the emulator where there wouldn't be support for this, then in this case, it's just going to print out a information message and fail out. Your program that you're writing has to do something more intelligent in this case. You have to find a different way to get the address to be mapped using the browser, the Google Maps, as opposed to using the native geo intent handler. If there is something for this, then I go ahead and I say start activity, and I pass off the geo intent to that activity. And as we'll talk about in a minute, that causes a new activity to be created, and that activity, which is a secondary activity, is then going to go ahead and know how to handle the address that was passed into it. And you can see that the address was defined as part of the intent data, which was passed in as a URI. We also said to Android, please find somebody who knows how to view this particular URI, which is the geo-based URI category. Okay, so that's the basic idea going on here. Your code is a little different from this, but it's along the same lines. Any questions about this particular piece of code? Pretty straightforward. The assignments will get much more interesting as we get further along. I just wanted to give everybody a chance to get up to speed if you weren't already familiar. So once you've created the activity and initialized it, we've got ourselves the buttons and the edit text and all the other stuff that was part of this. Then some other things are going to take place under the hood by the activity manager that Android is managing on your behalf as part of the system services. So after onCreate returns and everything is initialized, then the onStart method will get called automatically by the framework. That was that code we just looked at. It gets called when the activity's been launched. It says perform start. And this is what's called when the activity is about to become visible on the display of the phone. So it hasn't become visible yet. It's about to become visible. And the typical thing that you do in onStart is you either set the application state or reset the application before and make sure the behavior is properly ready to go, so that when the next thing gets called on resume, now you can start displaying things on the screen. Now, for the very simple example that we're doing here, this is overkill. But in more sophisticated examples, there's reasons why you want to defer some of the behavior until later, because it gives a more continuous appearance to the application user by using these various callback hooks in the right way. Now, notice when you start to enter the data, when I started to sit there and type on the phone, let's see if I can bring this up and show you what I'm talking about. There we go. All right, let's go to the home screen, and let's go to map a location. Okay, so when I start up here and I'm saying, whatever, 1600, Pennsylvania, blah, blah, blah. As that stuff is happening, this is just interacting directly with the widget. It's not causing any life cycle operations. But those things only occur at specialized times. By the way, as you probably already know, if you move your phone around, it'll change the orientation in different ways. Okay. So now the focus is on those particular widgets that are part of that activity that are initialized properly, and lifecycle events are not being generated. When another activity is about to start, the on-pause method of the current activity is called. And the intent there is basically to shut down or pause the behavior that's interacting with the display. If you didn't do that, chaos would break out. There'll be multiple things trying to scribble on the display. If you are curious, the circumstances under which on pause is called, there's a nice link in the bottom of the slide which goes into some detail about it. And so the basic way it works is that if an activity pops up that's going to occlude all or part of the current activity in some way, the on pause method gets called. And there's a distinction made between pausing something and stopping something, because it may be the case that part of the window of the previous activity is still visible even if a new activity has started up. The example, if you take a look at this link, the example they give is where you throw up an activity-based dialogue, not a capital D Android dialogue, but a dialogue written as an activity that only takes up a portion of the screen. In that particular case, the underlying activity will be paused, the one that was there before, but it hasn't gone away. It can't have the focus, and the current dialogue would have the focus. That would be an example. The toast example we talked about before is not one of those things. It actually doesn't cause there are other types of things that are activity-based that do that. If you're actually going to go away altogether, if your display is going to be completely occluded or completely blocked by another activity, then the on stop method is called on the previous activity. And the idea there typically is to cast away any state that you may need, so that when the activity that's blocking you goes away, you can go ahead and resume and restart or start what you're doing and have it look like it was when you left off. So you want anything else the user had been doing at that point to remain exactly the same way, so when it comes back, then you have the state redrawn the way it was before. And as you might expect, on stop is typically paired up with on start, and pause is typically paired up with resume. So when the map app pops up, that'll cause the underlying activity that we use to get the user to input the address to go into stopped mode. And in that particular case, that wasn't going to do anything, but normally you would actually do something there. So this slide is just reiterating that. When the new app starts, when the map activity comes up, it's on create and on start and on resume methods are all called back, and the previous activity, one that was prompting the user, on pause and on stop methods are called to get it to stop doing whatever it's doing and perhaps free up some resources. There's also a method called restart, which is a bit more mysterious, and so I encourage you to take a look at this URL to learn how and when restart is called. There's certain circumstances under which restart is called. Most of the time, it doesn't get called. And then the last method we'll talk about here is on destroy, and on destroy is what's called back when your activity is about to go away, like when the user presses the back button. and that's used to clean up any state, free up resources, and potentially if there's something the activity has done that needs to be stored persistently, then that's a good place to do that. Although people might argue that you're better off using on stop to do this rather than on destroy. Does anybody know why it's typically recommended to do on stop versus on destroy? Along those lines, right, there's another thing, Patrick. Someone could kill it. So the system might unilaterally decide to kill it, or someone might open the task manager and might kill this thing. Get shut down in a way where the on-destroy method wouldn't get called. So that's why you would typically do some things. It's harder to that on-destroy is called. On-stop is typically called whenever you're blocked from being able to make something. Okay, so a couple more things, and then we'll do the quiz just to round this out. So how do you start activities? The typical way to do this is you create an intent, and then you invoke one or more hook methods to get, or one or more Android methods to get the activity started, using the intent as a way to start. By the way, something else I want to point out real quick here, if you go back. Notice how when we wrote this code, we didn't say, Android, start up the browser. We didn't say, Android, start up the Maps app. We didn't say that at all. We just said, Android, here is an intent, and here's the data I want you to work on. Go find somebody who knows how to view this intent. And so what happens is that intent, when we call start activity, that intent is used with the intent framework to find all the things in the phone that know how to view geo your eyes. Now, it turns out the map application is the one that gets preference there. But had we used a different interface, and you'll see this when you start playing around with this on your phone, sometimes it's ambiguous which app should handle it. In which case, you'll typically get a little dialogue chooser, or you can explicitly say, I want this activity, or I want this application to handle this kind of event, intent. And then you can also say, and henceforth, always make that the default. There's a couple different ways to customize that. So we basically have the intents framework used to select the appropriate handler for the intent that was created in the first activity, and then that's used to create a handler or an application to run the intent to handle it in different ways. There are two methods that are typically used here. One is called start activity. That's the one we used here. It's very simple. It typically is used when you don't expect there to be a direct result coming back. There are lots of ways to get results back when you start activities, but you're not expecting one to come right back to a well-defined way that you define it. And then the second way to do it is to use start activity for result. And start activity for result actually is used when you intend to get a result back from whoever's the activity that you're spawning. We'll talk more about that in a second. For our example we looked at right here, we're using start activity. You can see there, we're creating the intent and then just saying, go to town, start this thing up. We'll look in a second at another example that uses start activity for result. Okay, so any questions about any of that stuff? If you look at the code that I have here, you should be well on your way to figuring out how to do your application with a few other tweaks, like you can't hard code the button registration, you have to use the XML files and the layout files and so on to do that. Next example, which we'll use to wrap up right before the quiz, is to illustrate the use of start activity for result. So in this particular case, we're going to get the map location from our contacts on the phone, and that's a more interesting use case. So let's go ahead and run that example, and hopefully everything will work. Map location from contacts, apply, run, and we want to run it on this thing. Okay, then hopefully this is working. There we go. Okay. Now you can see it no longer gives us a prompt for entering the address. It just gives us a button that says find address. So I click find address, and what's going to happen is it pops up my contacts list. And this phone is not a phone I use very much, so my contacts list is in a bit of disarray. But if we look in here, I can find me. And what do you know? I have magically decided I live at the White House. And so it'll go ahead and search. It'll look in my address field, in my contact entry, and then go use that and find that. Obviously, a little bit presumptuous, perhaps, but that's the way it works. So that's basically what it's doing. And if you come back over here, go over here and find people, find me, and go look, find there. Indeed, that is my home. Like I said, I don't use this phone very much, just for demos. So how does that all work? And number one, notice how we were able to reuse large chunks of code without having to do anything, right? We just used existing software to do this cool behavior of getting our people finder, our direct address book, to be able to locate stuff. So here's what this looks like. As you can see, a lot of it's very much the same. The main difference is that I don't have all the other fancy code here to check to make sure I'm running on the right device. I just assume I'm running on the phone at this point. And down here, I create the intent. And this time, I say, I want you to find something that will pick from a list of things. And I want that list to be the list that is handled by the contacts. The contact part of the phone. The activity knows how to handle that. So I do start activity for result, and I say, here's the intent, and I also pass it in this magic cookie called pick contact request. That indicates this particular invocation, because there could be lots of things going on. We'll talk more about that later. So what I'm basically saying is I'm saying, Android, go find me something on the phone that knows how to give users a list of contacts that they want to choose from. And that's all handled under the hood. You don't have to write that code. Somebody else wrote that code, it comes out of the box. And then when it's all done, there's a method called onActivityResult. It gets called back automatically by the Android framework. And it gives you a couple of things. It gives you the request code, which says, the request code, which was what we passed in. This is the pick contact request. And it gives you back the result code, which said, did it work or not? So assuming it worked, and it was the pick contact request that we're getting called back for, then we go ahead and do a bunch of other magic that we'll talk about later in the course. Don't worry about it right now. We get ourselves a content resolver, which is actually a way of accessing the content provider. And then we do a bunch of magic with cursors and queries and so on and so forth. And we go ahead and putz around here. And basically what we're doing is we're extracting out the information that was part of the address portion of the contact. And then we're going to go ahead and create that into what we're going to use to tell Android, please find me a viewer that knows how to view this particular address. So it's pretty cool. So we're using this particular activity that we wrote, one to use the context list, to start activity with result, to set up the people finder chooser menu. We select the appropriate entry, and then on that entry, what's given back as a callback to the onActivityResult callback method is enough information to go look up and find what's happened, and then be able to extract from the entry we got back the person's address. And we use that to spawn another viewer. So you can see it's interaction, kind of passing things back and forth. So very, very cool, very simple thing to do, but incredibly powerful. And for those of you who are familiar with pipelines, this is not unlike the concept of pipelines being connected together, but it's more powerful because it's more like a graph as opposed to the pipeline. This kind of talks about how to do start activity for result, shows the code we just looked at, and that's basically the end of it for right now. Okay, any questions about anything we covered? So at this point, you should be pretty well armed to do the programming assignment. On Monday, we're going to talk about some other things that you'll have likely encountered as you're doing the programming assignment. But please do not wait till Monday in order to start it, because it'll be rather painful.